method. Before I start, I want to welcome you once again in our afternoon lesson of day 2, week 4. Yes, good afternoon. It is good afternoon right now. Good evening. Evening starts at 6. Yeah, 6 p.m. Okay, so good afternoon to you all. I hope you are all fine. Please stay muted. Okay, so at this time, I want us to go through what we had yesterday. Yesterday, I know we talked about electricity, and I'm just going to ask very few questions verbally, and we answer. We said electricity and magnetism was the topic. Before I introduce another topic, before I introduce a new lesson, I want us to go through what we had yesterday. The question is, what is electricity? What is electricity? What is electricity? Ethan, thank you. I've seen your answer. That's very good. Very good. It is always to be very active and very fast the way he does. And I think everyone does so. So let us be very fast and very active. Electricity, I've seen the answer. That's okay. Yes, Daniela, give me the answer.
Electricity is the form of energy by charges.
Very good. Electricity is a form of energy produced by charges. Okay. So we said we have, for electricity to take place, there's charges that are supposed to be around. Can you give me the two main charges that you know? Two main charged particles that you know. The charged particles that you know. Charged particles which are involved in electricity. Thank you, Lavet. I've seen your answer. Yes, Katende. Katende, Colin, give us the answer.
Positive charges.
I say I want their real name, not the description. Okay, Ethan, thank you. I've seen your answer. Desire, what do you think? Are there real names? Can you give me the names of those charged particles? Nalugwa, thank you. I've seen the answer. We're talking about the charged particles that happen or that take place in electricity. Okay. Mariam. My friend Mariam, give us the answer. Charged particles. Okay. Mariam's off. Ethan.
And electrons.
Okay, we have electrons, protons, and neutrons. Okay, what name is given to, or what are protons? What are protons? Can you give me the answer? What are protons? Love it, thank you. Love it, I've seen your answer. Thank you. What are protons? What are protons? Yes, Chimuli Carol.
Protons are always positive charges.
Are you defining or you're telling us?
I was telling you.
Okay. Okay, thank you for telling us. All right. What if it is a paper? Someone tell us. Love it. Give us the answer. What are protons? Love it. Give us the answer. What are protons? Nalugwa, what are protons?
Protons are positively charged particles.
Okay, thank you. Protons are positively charged particles. So we said protons are positively charged particles. electrons and negatively charged particles, right? That's what we looked at yesterday. We said we have two types of electricity. Can you give me types of electricity that you know? Peace Sunday, give me one. Types of electricity. Peace Sunday. The types of electricity. Okay. Thank you, Pony. Thank you, Pony. I've seen the answer. Thank you, Ethan. I've seen the answer. Jeremiah, I'm waiting for yours. Okay. Types of electricity, we said we have static electricity, we have a static electricity and current electricity. Only two types. We have static electricity and current electricity. We said static electricity. Can you give me example of static electricity in nature? Example of static electricity in nature. Example of static electricity in nature. Love it. Thank you for your answer. I've seen. Atukunda, you're not talking. I don't know why. Ajram, I'm waiting for you. Ethan, thank you. Others can use the chat, please. The one who's using Techno, WXP, I don't know, is it Lonkuse? Is that Lonkuse? If you know you are using Techno, that one of the screen, give me your name. I want to write here your name. Okay. So the answer is lightning. Thank you, Katende. Thank you, Lavet, and whoever has sent the answer. That's an example of static electricity in nature. So we said today we are going to look at something. We shall have extension of lightning or about lightning. We had introduced it yesterday, and in today's lesson, hope you can see it is our week 4 and day 2. We're having P7 work, that is the second term. I mean, first term, second topic. So you should know we are progressively moving. Besides being in lockdown, but we have at least been able to cover, and we shall be in position to cover the content in this time. By the end of today's lesson, all of us shall be in position, or will be in position to describe how lightning and thunder are formed. We shall be in position to mention the dangers of lightning. We shall mention the dangers of lightning, to state how, or to state ways or how we can protect ourselves from lightning. So basically today's lesson, we are still on static electricity, and we are going to look at how we can defend ourselves from lightning, the dangers of lightning and how it takes place. On this screen, you can see lightning and thunder. I hope you can see that, lightning and thunder, right? So without wasting time, let us start. Here we have just a few minutes, 5 minutes on this slide. Okay, so number one, we are saying lightning and thunder. Of course, yesterday we looked at each and said in nature, static electricity takes place in the clouds as they move, rubbing a layer of air. So here we are going to look at how lightning takes place. It takes place when a negatively charged cloud meets a positively charged cloud. Of course, it takes place between collision or due to collision of clouds to collide. When these clouds collide, clouds of different charges. We shall have a cloud of positive charges and a cloud of negative charges. So when they take place, a huge spark, you know, spark, not Spark TV, but we're meaning that the fire. So the huge spark will take place, or huge light will take place, and that spark is what we call the lightning. So how does lightning take place? Lightning takes place when a negatively charged cloud collides with a positively charged cloud. I hope you are getting me there. It takes place when a negatively charged cloud collides with a positively charged cloud. So the huge spark causes the air around to expand, and contract immediately. So that air around will expand. Of course, when it is heated, you know, effects of heat on matter, it expands matter. So when that air around the clouds, those two clouds, is heated, it will expand. And when it expands, it contracts at once and it makes a louder sound. That sound that it makes, it's what we call thunder. So remember, we said two things first happen, first meet, the positively charged and the negatively charged clouds. They collide and they produce spark, which is called lightning. Now that heat, that spark, causes the air around those two clouds to expand and contract. Thereafter, producing a loud sound that's called which is called thunder. Therefore, you should know that lightning is the light and the thunder is the sound. Altogether, these two things are different. They are not the same. Lightning, it is not lightning, it is lightning. Lightning is the light and the thunder is the sound. Altogether, we are saying lightning and thunder are formed at the same time, but we see lightning first. So these things, or these two things, occur at the same time. But when we are seeing, or in our observation, we see our lightning faster, or we see that light faster than we hear the sound. So that question is very, very, very common. The question is, why is lightning seen? Why is lightning seen before thunder, or before sound of thunder is heard? Of course, you cannot hear lightning, but you can see what? You can see it. And you cannot hear, you cannot see thunder, but you can hear it, because thunder is the sound. And of course, we don't see sound. If you are there and for you see sound, I don't know which creature you are, but we cannot see sound, we can only hear a sound. Then light, you cannot hear light, but you can see light. So the question is, why is lightning seen before thunder is heard? Or why is thunder heard before lightning? Why is thunder heard after lightning? The answer is very simple. It is because light travels faster than sound. These are two forms of energy. Yesterday we looked at the forms of energy. These are two forms of energy. There are two forms of energy. Altogether? Is that okay? There are two forms of energy. We have light energy and the sound energy. So light energy travels faster than sound energy in air. Therefore, that's why we are in position to see lightning faster than we hear the thunder. So the answer is light travels faster than sound. Let's look at importance of lightning. How is lightning useful to us? How is lightning useful to us? Lightning, number one, we are saying it helps to fix nitrogen in soil. To every crop farmer will benefit if lightning occurs, and every plant will benefit if lightning occurs. How? Lightning helps to improve soil fertility by fixing nitrogen into the soil. Because that light, as it is traveling to soil, in the sky we have what we call nitrogen. So that nitrogen gas or nitrogen compounds are fixed into the soil, and of course our plants will be in position to absorb the nitrogen and hence use them to make different food nutrients, most especially proteins. So how is lightning important? Lightning helps to fix nitrogen in soil. That is very simple. It helps to fix nitrogen in soil. Dangers of lightning. I repeat, dangers of lightning. You know very well lightning is very dangerous. Number one, it kills people and animals. That's number one. It kills people and animals. Number two, it destroys buildings. It destroys what? Destroys buildings. Another one, it damages electric appliances. You know, when lightning strikes you, or when that lightning strikes you, you can die. Even if it is an animal, it will be in position to die. It destroys buildings. That's why most buildings are protected with the lightning protective gears or devices. We shall look at them. Because it is dangerous, it destroys buildings. It damages electric appliances. When I say electric appliances, I mean machines or devices which use electricity, be it a phone, laptop, fridge, or electric kettle, anything as long as it uses electricity. When lightning strikes, yes, it can pass through of course, that current, and it reaches to electric appliances, hence making them damaged. So dangers, importance, it fixes nitrogen in the soil. Dangers, it kills people and animals, or it can lead to death of people and animals, or it can lead to loss of lives. It destroys buildings and damages electric appliances. Protection against lightning. Protection against lightning. Protection against lightning. So how do we protect ourselves against lightning? That's the question. How do you protect yourselves against lightning? In case it is raining, what will you do? Number one, you place lightning conductors. They are called lightning conductors or lightning arresters on tall buildings. When I talk about tall buildings, of course, you know what I mean. The flat houses, the skyscrapers, all those tall buildings are protected with what? With the lightning conductor or lightning arresters. That's just a metallic strip that is put above or on top of the roof in order to trap lightning or to trap those charges. So you have to put it on rooftop so that it helps you to trap or to protect your